Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide focused on DTC P16EB, which indicates a LIN communication error connected to the Powertrain Control Module, PCM, concerning the active exhaust system in the Honda Civic models from 2022 onwards. The active exhaust system plays a vital role in managing exhaust sound levels and performance by utilizing actuators controlled by the PCM to open and close the exhaust valves based on driving conditions. If the PCM receives inaccurate information from the active exhaust valve actuator, it will flag this as an error, resulting in the P16EB code being stored. This indicates that the PCM is unable to communicate correctly with the active exhaust's LIN circuit. In this presentation, we will delve deep into the causes, effects, and precise troubleshooting steps to rectify the issues associated with this DTC. By following these guidelines, you can ensure systemic identification and resolution of the underlying problems. DTC P16EB signifies a LIN communication error involving several critical components. The Powertrain Control Module, or PCM, orchestrates the overall vehicle behavior, including engine performance and emissions control. It is situated in the engine compartment. The active exhaust valve actuator is a key component that regulates the exhaust sound, located on the exhaust system, connected directly to the PCM. The 12-volt battery sensor monitors electrical efficiency and informs the PCM of voltage strengths. It exists close to the battery. Lastly, the alternator maintains the vehicle's electrical supply, being located near the engine and providing power to the electrical systems. This error typically arises when the PCM cannot correctly interpret signals from the active exhaust valve actuator due to wiring, circuit faults, or component failures, leading to performance issues in the vehicle's exhaust system. There are several potential causes behind the LIN communication error indicated by DTC P16EB. A faulty active exhaust valve can hinder proper opening and closing operations, disrupting communication with the PCM. Wiring issues are another common culprit. Damaged or corroded connectors or wires can obstruct the flow of electrical signals necessary for proper actuator operation. If the PCM itself is malfunctioning, it may misinterpret the data it receives from the actuator, leading to erroneous error codes. A faulty battery sensor can compromise voltage readings, which also affects communication lines, particularly the LIN circuit, resulting in a disconnect between the PCM and the exhaust actuator. Therefore, it is essential to inspect each of these components thoroughly to identify the specific cause of the issue. Identifying the symptoms associated with DTC P16EB is critical in diagnosing issues correctly. First, you may notice poor exhaust sound management. The active exhaust function might not work as intended, leading to a louder or inconsistent exhaust note. Secondly, engine performance issues could occur, manifesting as reduced power or unusual behavior during acceleration, since the exhaust system is integral to engine operation. Thirdly, fault codes will likely appear when performing diagnostics, indicating that the communication between PCM and actuator is compromised. Lastly, you might experience reduced fuel efficiency due to the engine not functioning optimally when not correctly calibrated. Recognizing these symptoms will guide technicians in determining if further diagnosis is warranted. The first step in troubleshooting DTC P16EB involves confirming whether DTC P16E2 is present. This serves as a preliminary check that can help pinpoint additional related issues. To begin, access the vehicle's diagnostic tool and check for codes. If DTC P16E2 is indicated, it suggests that there may be overlapping errors that require attention. If P16E2 is not present, it points directly to issues strictly related to the active exhaust components and communication. A clear understanding at this point allows for a more targeted approach in subsequent diagnostic steps. The next phase is to inspect the external circuit, particularly focusing on the wiring and connections of the active exhaust valve, ground, GND, and the LIN battery sensor circuit. Start by ensuring that there are no visible signs of damage or corrosion on the wires connected to the active exhaust valve actuator. Use a multimeter to measure voltage continuity in the relevant circuits, specifically checking the LIN communication ability and ground connections. Circuit inspections should ascertain that all circuits exhibit appropriate resistance levels, typically aiming for less than 1 ohm of resistance. If abnormalities are detected during this inspection, follow up with further diagnostic procedures that target the circuit faults to ensure they are resolved. Following the external circuit inspection, the next step is to investigate the active exhaust valve actuator itself. Start by disconnecting the actuator's 3P connector for safe inspection. Once disconnected, it is critical to check the actuator's internal circuits for any sign of shorts or other faults. Utilizing a multimeter, verify whether the actuator shows continuity and electrical specifications as outlined in the service manual. If the actuator appears shorted or fails to meet operational standards, this component may need replacement. Proper handling is essential during this step to avoid additional damage and ensure all connections remain intact during testing. The next step involves inspecting the Powertrain Control Module, PCM, for any functional issues. If previous inspection results indicate no faults in the active exhaust valve actuator or external circuits, it may indeed be the PCM that is at fault. To diagnose this effectively, utilize the diagnostic tool to check the PCM's responsiveness and its ability to communicate accurately with the vehicle components. This may include performing advanced tests or system resets as prescribed by diagnostic guidelines. Ensure that any relevant error codes are documented and addressed during this investigation. Should the PCM fail to communicate or show any erratic behavior, replacement or reprogramming may be necessary to restore full functionality. After completing all necessary inspections and repairs, it is paramount to conduct a final verification of repairs associated with DTC P16EB. Start by re-scanning the vehicle system to ensure that no DTCs are present, especially those related to the active exhaust module and PCM. Following this, a test drive is imperative to validate that everything operates effectively under real driving conditions. Pay careful attention to the exhaust system's behavior during acceleration and deceleration phases. In particular, make sure the active exhaust valve operates smoothly. Any irrational responses or further issues should be addressed immediately to ensure the vehicle's performance is restored to optimal levels. Preventive maintenance plays a crucial role in avoiding future occurrences of P16EB and ensuring overall system reliability. Regular inspections of wiring and connections associated with the active exhaust valve actuator can drastically reduce the likelihood of communication failures. You should adopt a schedule for parts replacement based on manufacturer recommendations, especially for components prone to wear and tear. Furthermore, maintaining clean connectors can minimize corrosion risks, ensuring a strong connection across all electrical circuits. Implementing these preventive measures not only helps in maintaining the domain's effective operation, but also keeps the vehicle in excellent condition. In conclusion, troubleshooting DTC P16EB requires a systematic approach to accurately diagnose the communication errors affecting the active exhaust system. Identifying symptoms early on allows for quicker diagnosis and resolution of issues, effectively enhancing vehicle performance. Following agreed-upon inspection methods helps narrow down the possible causes and aids in efficiently isolating the faulty component. Finally, maintaining every connection and ensuring regular inspections minimizes future risks of encountering DTC P16EB again. This structured methodology not only resolves the immediate concerns, but also contributes to the longevity and reliability of the vehicle, upholding Honda's reputation for high standards and quality assurance. Please like and subscribe to the channel. See you next time.